So your first cat is coming up. It's when is the first cat?
August.
August? Not August. When is the first cat?
September.
Hmm?
September 6th.
September
September 6th. Yeah.
6th.
First cat is September 6th, Friday, 10:30 to 11:30. Okay. So right. Can you all see my screen?
Yes, sir.
Yes.
All right. So I hope you went through the previous day school. Any doubts from the previous lecture? Any doubts from the previous lecture? Let me close this one. Yeah. Then. Do you have any doubts from the previous day school? Could you have some time to
No,
do that?
sir.
It was okay. Right. So we had a compulsory day school last week. Just to recall some level 3 stuff. Um, let's continue that one. I hope we can finish everything today. Then after today, then you can start studying. This is my last day school on the second book, Unit 2, Chemical Kinetics. Okay. So before starting the day school, I have a slide just to motivate you guys. Right. I hope I have explained this one in the previous one also. If you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you, right? So now you are in level 4, right? At the beginning of this semester, so I just wanted to give you some advice, right? So no one can help you if you are not willing to learn. Even we cannot help you. So we are here as teachers or as mentors. We can only help you if you are willing to learn. Right? Let's say the next cat is coming up. First of all, what you have to do, as Dr. Dusanta mentioned, you have to find some time and go through our lectures. First, go through the compulsory day school stuff. Then after that, go through the regular, this day school's content. Then after that, you have to start reading your book. Without reading your book, you cannot face the CAT exam. Because most of the questions for the cats, they are coming from the course material. If you do not study the course material, how can we face the exam, right? Therefore, please have that will in your uh, actually journey, right? Because you are going to graduate soon. Therefore, please work hard. Then set goals to achieve your dreams. Without setting goals, you are not going to do a good job, right? Just think after this semester, after this year, who you want to be. This is a critical year, because if you get good grades, you can apply for the special degree, right? Right. So one of your goals would be doing a chemistry special, right? So likewise, please set some goals. So I'm not telling everyone to do chemistry special or whatever the special, but you should have some goals. I want to be a teacher. I want to be a researcher. I want to do a master's degree after this one. Therefore, I would work hard to get a general degree with the class. Then after that, I want to go abroad, right? Just then do my PhD or whatever, likewise. So set some goals, right? Don't forget about the past. It is gone. Past is past. Now you have time to start working, right? Therefore, after this one, please try to find all the past papers and work on the question. There are some additional questions on OULMS and in your course material too. Please work those questions as well. we have created an official Telegram group for everyone. So you should get the benefit of that one, right? So students barely ask questions. Please do so. Let's say the other student, I know there are very good students in this group. Those students can also help your friends, peers, right? So sometimes Dr. Dusanta, Kumudika, and me, we are busy with other work. If someone asks a question, please answer, right? Because you have to work together. Then only we can win the game. All right? Good. Any doubts? Ready to go? All right. So we discussed about the Arrhenius equation the other day, right? We discussed about the Arrhenius equation the other day. What is the Arrhenius equation? Can someone recall? Students, you have to talk now. What is the Arrhenius equation? Hello? Can you hear me?
Yes, sir.
What is the Arrhenius
Yes, sir.
equation?
K is equal to
K is equal
A
to
e to the
A
power
into
of
E to the power
minus
minus
delta EA over RT.
Yeah, very good. Here is the Arrhenius equation. K is equal to A times e to the power minus EA over RT. K here, K is rate constant. Don't write capacity or conductivity or any kind of thing. K is rate constant. A is the pre-exponential factor, Arrhenius constant, right? That's not the area or something else. E is the activation energy measured by joules per moles, most of the time kilojoules per moles. T is the absolute temperature, not just temperature, absolute temperature, which means measured by kelvins. Then R is the gas constant measured by joules per kelvins per mole or universal gas constant, right? So please have these ones, special important ones in your short note, right? Don't write lies for the exam. It's a shame when you write R, when you identify R or when you name R as the resistance or something else. It's a shame, right? I'm telling you, because you guys are level 4 students. Okay, first activity. Transform the Arrhenius equation into linear form. Okay. So I told you that you have to work with me, right? I will give you maybe just 1 minute is enough. Do this activity. So you should have your notes with you and to work out the things, maybe some additional papers, do this one. So these are the question types that I'm going to ask for the CAT exam or maybe for the final exam. So it is very sad that, so this is the truth actually. Some students cannot even correctly write the Arrhenius equation. That's not an excuse, right? They don't know how to transform the Arrhenius equation into its linear form. If you do not know these fundamental things, how can you pass this course? Then after you don't work, actually you don't spend time, then you just lightly take this one. Then after that, you just cry when you are ready to graduate. So I have a C minus for this one. I have a D plus. Is it possible to change the grade? No. How can you change the grades? It's not possible. So don't come with those silly excuses or whatever in the future, right? So we are spending the maximum of our time for you guys. So you don't get, if you don't get that one, that's your problem. That is not our problem. Okay. All right. So what is the answer? What is the linear form of the Arrhenius equation? Anyone?
L and
K equal minus
L and
T is
K is
equal
equal
to
to L and
minus
K.
E A
Mm-hmm.
over R
Then
plus ln.
plus ln. Very good. Here. So k is equal to a e to the power. E is exponential. Do not write for e, that is the charge of electron, right? You don't need to describe e. E is exponential. We know that one. You don't need. We only expect these four. Right? So then take the logarithm, natural logarithm of both sides. Ln k is equal to ln this one. It's a product. You know that when you have a product, how do you do that? Because I'm just recalling these ones. Log, let's say log AB is equal to log A plus log B. You know this row. Then that is ln A plus ln e to the power this one. What is ln? Ln means logarithm of something to the base e. Right? Then now you have logarithm of e to the power minus EA over RT. So now you can take this part in front of that, minus EA over RT, logarithm of e to the base e. We know that logarithm of e to the base e is equal to 1. Right? ln e is equal to 1. Therefore, ln k is equal to minus EA over RT plus ln a. So this is the linear form of the Arrhenius equation. Right? That's easy. Then, so you can plot a graph if you want to find something. So these type of graphs actually may be structured essay questions or essay questions, right? So let's say you plot ln k versus 1 over t. The y-axis is 1 over t measured by per kelvins, k minus 1. For y-axis, you don't have units because logarithm terms or exponential terms, we don't define units for these ones. The unit is 1. The gradient is equal to the y distance divided by the x distance. The y distance, y1 minus y2, x1 minus x2, you have to find 2 points which are on the line, and there should be some distance between those 2 points. So find 2 points far away on the line. Right. So what is the unit of the gradient? The unit of y-axis is 1. The unit of x-axis is per Kelvin. Therefore,
Kelvin.
Kelvin. Yeah, very good. The units of gradient is Kelvin. Now, what is that? The gradient is equal to this one, right? The gradient is equal to minus EA over R. So since this has a negative slope, you will get a negative value for this one, for gradient. Then that negative value and this negative value cancels off. Therefore, you will get a positive answer for EA, right? You will get a positive answer for EA. The unit of gradient is Kelvin. That's what you have to know. The units of this one, therefore EA is equal to minus M times R. Please remember that this is a negative value because this graph has a negative slope, negative value. This negative and that negative will be positive. Therefore, E naught, this is a positive value or greater than 0. So here you have kelvins multiplied by joules per moles per Kelvin. Now, this one and this one cancels off. What is remaining? Joules per mole. Therefore, the units of E is joules per mole. The activation energy, it's joules per mole or sometimes kilojoules per mole. Is that clear, students? Any doubts?
No, sir.
No, sir.
Good. Right. The next one. Right. Zeroth order reactions. I hope you can remember. Right. Just to practice, those who went through the previous notes, I will give you maybe 2 minutes. Obtain the rate equation. Obtain the rate equation and apply integration and just do some work. I'll give you 2 minutes because you also have to practice these ones. Otherwise, you cannot learn kinetics. Okay. zeroth order reactions. All right. So how do we start this one? A gives products. This is how you write the rate of the reaction. I explained everything in the first day school. Please go through that one. Minus dA over dt. That is how you represent the rate mathematically using differentiation. Minus dA over dt is equal to k times a to the power 0 y 0th order. You know that a to the power 0 is 1. Therefore, dA over dt minus is equal to k. Now, so this step, these are differential equations. You have to simplify these differential equations using integration to obtain the relationship between the concentration and time. That is what we are going to do. Now, this step, separation of variables. This part, dA part, you just write here, multiply by dt, and minus sign is there, minus k dt. Now you have to integrate both sides. So here the variable is concentration. The concentration changes from A naught to A. At time 0, the concentration of the system is A naught at the beginning. At time t, the concentration is equal to A. Then A naught to A, time varies from 0 to t. Right? You know that when you integrate dA, I explained that one. All these things we covered in the first one. Please go through that one. When you integrate dA, you will get A from A naught to A. When you integrate dt, you will get t from 0 to t. Then you apply the limits and you will get that equation like this. Therefore, A is equal to minus kt plus A naught. This is just like y is equal to mx plus c. Y is equal to mx plus c. Right? So here also, if you want, you can plot a graph. The y-axis is concentration of A, x-axis is time. Then it has a negative slope. M is equal to minus K, right? M has a negative value itself. Therefore, negative cancels off. You will get the value for rate constant. You can experimentally determine the rate constant of this reaction. So how do you calculate the gradient? Gradient is equal to y distance divided by x delta y over delta x. So what is the unit of gradient now? What is the unit of the y-axis?
Mole decimeter minus 2.
Mole, yeah. In normal units, moles per decimeter, right? Because this is concentration. Then the
Second.
x-axis is time, that is second. Therefore, the units of gradient is
Mole per decimeter cube per second.
moles per decimeter cube per second. Very good. Right. Right. If I ask this question, what is the half-life of this reaction? How do you do this? What is the half-life of this reaction?
The final concentration will be half of the initial concentration.
Yes. When time is equal to t half, the concentration of A is equal to what? A naught divided by 2. Then apply this one. This is A naught divided by 2. Okay, my bad. A naught divided by 2 is equal to minus K T is T half plus A naught. Then KT half is equal to, then take this side into this side and this term into the other side, right? Then that is positive. Then A naught over 2 plus A naught. Am I correct, students?
Yes, sir.
Okay. So now, okay, so no, there should be a negative sign, no? Right? So I'm taking this part into this side and taking that part into the other side. Then what is the answer? K times T half is equal to here minus half plus 1. What is the answer? A naught over 2. Therefore, T half is equal to what? Then divide by K. Therefore, the T half is equal to concentration of A at the beginning divided by this. Is that okay? Clear? Right. So that is the T half value for the zeroth order reaction. T half-life, that is known as the time taken for the reaction to get its concentration half of the initial concentration. All right. So that's all about zeroth order reactions, derivations and everything. Is that clear? Anything that you could not understand?
Yes, sir.
Okay. Then let's go to the next one. First order reactions, right? First order reactions, same thing. I'm not going to spend much time, right? The rate A gives products, the rate minus dA over dt is equal to K times A to the power 1, since it says this is first order. Now separation into variables 1 over A dA K dt times minus K dt, separation of variables. Now you have to integrate from A naught to A, from 0 to T. When you integrate 1 over A, that is ln A, limits are from A naught to A. When you integrate dt, answer is T, from T to 0 to T. So now please remember that you should know some mathematics. Please go through your level 3 notes. Otherwise, join the level 3 classes now we are conducting. If you cannot remember, we just started unit 1. So after maybe next week or maybe after the third week, we will cover differentiation and integration. Join the classes. If you cannot remember, please learn, don't give up, okay? So then after you integrate, then you will get ln A, then apply the limits, then simplify the equation, then you will get the linear form like this. This is called sometimes the integrated form. So this is the differential form of the rate law, right? Differential form. This is called the integrated form. And please know these names also. Differential form, because d over dt is the integration. You know, you will get ln terms after you integrate on. Again, you can plot this one. The y-axis is ln A, concentration of A. X-axis is T. Right now, you can find the gradient delta y over delta x. What is the unit of x-axis? Y-axis 1. What is the unit of x-axis? S. Therefore, what is the gradient here
Second one.
per second? Right? It is time per second. Right? Here y is equal to mx plus c type. Therefore, the gradient is equal to minus k. Gradient itself has a negative value. Therefore, the unit of the rate constant is also Kelvins. Sorry, per second. For first order reaction, the units of the rate constant is per second. What was the unit of the zeroth order reactions? Can you remember?
Mole decimeter minus 6 second minus 1.
Yep, very good. So this is for the zeroth order. So this is for the first order. So you have to remember these things. Right? What's next? Activity. So again, very easy. Determine the half-life of this reaction. When the time is half, the concentration is equal to A naught over 2. then apply in this equation and get that value. T half is equal to ln 2 over k. So earlier, what did you have? T half is equal to concentration of A at the beginning divided by 2k. So this depends upon the initial concentration of A, right? It depends upon the initial concentration of A. But here you don't have that one. It's a constant. You know that rate constant, it's a constant at when the temperature is constant, right? So it will not vary here. But this one depends upon the initial concentration of the reactant, right? Some idea. Okay. Then we discuss about this one also, pseudo first order reactions. Pseudo, fake. Consider this example, reaction A plus B giving products. Okay. So how do you write the rate law? Minus dA with respect to A, okay? Minus dA over dt is equal to K times. So these are elementary reactions. First, consider this one elementary, right? Or the second order reaction. Right? Consider that elementary, which means stoichiometric coefficients are equal to the order of the reaction, K times 1, A to the power 1, B to the power 1. Right? Overall, this is a second order reaction because the overall order is 2. Okay. Now, let's assume this one. So, A plus B giving products at time t. At time 0, let's say you have 1 moles of A and 1000 moles of B, or moles per decimeter cube concentration. Then let's say the dissociation is 0.1. So you will have 0.1, okay? Then if the dissociation is 0.1, then it will dissociate point from this one, another 0.1 from this one. Then when time is equal t, you will have 0.9 moles per dm cube of A, 999.9 moles per dm cube of B. Now what can you tell about this situation? The concentration of B is greater than concentration of A. You know this one, right? The concentration of B is greater than concentration of A. Yeah, that's true. When you have a situation like this, therefore, the change in concentration of B, here, the change in concentration of B is negligible or no change in B. Because earlier it was 1000, now it was 999.9, no change. Therefore, you can consider that the concentration of B has not changed after the reaction. Therefore, this is a constant. So now you can combine this one and this one together. K is a constant, B is a constant. Why? Because we have maintained a very high concentration inside the reaction mixture. Now, assume that the new rate constant is K into B is called K dash, where K dash is called the pseudo rate constant. Now you can reduce this equation because earlier it was a second order reaction. Now you have a first order reaction. So it is easier to deal with first order reactions than second order reaction, right? Now, again, you can separate into variables and follow the stuff we studied before and obtain an equation for the pseudo first order reaction. The only thing that changed was instead of K, now you have K dash. Here K dash is what? The pseudo rate constant. So this also has a Y is equal to mx plus C type graph. Is that clear, students? Anything you want to ask? Right. So in the lab actually, so you will study these ones when you do level 4 practicals in the second semester, right? So I will teach you how to obtain rate constant by carrying out these type of experiments. But you should have some theory knowledge, otherwise you cannot proceed. Right. What's next? Okay. So up to that, all the stuff. So this up to here, all the stuff that we discussed, that's level 3, right? If you cannot do anything up to here, I would say that is a shame, right? That is a shame. You don't know level 3 stuff, first year stuff. Therefore, please spend much time on these ones and improve yourself. If you cannot understand, talk to your peers. I know there are lots of very good students in this group actually. So you can just get their help. Right. Now we are going to start actual level 4 stuff. So I know that after this lecture, I have done everything in the book. So this, my lecture notes, it's complete. You can just study this one. There are some typos in the book, right? We will fix that later, right? But don't worry about that one because you have a very good note here. The first thing you have to study, so we are going to study in level 4, the complex reactions, right? So under complex reactions, first one is multi-step reactions. Okay. So these ones are also kind of level 3 stuff, but we study in level 4. Let me explain this one using this activity. Consider the two-step reaction between NO and H2, right? And answer the questions below. So this is the type of the questions you will get for the finals or CAT exams. If it is structured type, if it is MCQ, we will discuss more questions. 2NO gas plus H2 giving N2 plus H2O2 gas slow. So when this one is slow, what is this reaction is called?
Rate determining.
Rate determining step. This is a reaction mechanism. The slowest step is called the rate determining step. So you should know that. The rate constant of this one is K1. The second step is the formed H2O2 molecules further react with H2 to form H2O molecules. The rate constant is K2. This is a fast reaction. So by combining these two reactions, you can obtain the overall reaction, which is called the net reaction. Right. Now, my first question is, write the rate law for the decomposition of nitric oxide. Write the answer. Write the rate law for the decomposition of nitric oxide. What is the answer? So you have to consider the two reactions given here in the reaction mechanism. So which step involves NO? First one or second one?
First one.
Then therefore you have to consider the first one. By looking at the first one, write down the rate law. What is the answer? That's okay if it is wrong. Tell me the answer. We can fix that because we are here to learn.
Minus half NO over dt.
Rate law. It doesn't say rate. It says rate law.
K
Okay, sir.
into half d no over dt minus
K into. If you say
K1,
K into
K1.
no marks.
Okay. K1.
K1. See, some silly mistakes. So I'm glad you told that answer because you are doing that mistake in the exam. You write K, no marks, because it's K1, right? Okay, first one is good. Because, so question is asking the decomposition of nitric oxide. It's here, decomposes, which means it actually consumes. So the rate is dNO over dt, usually dNO concentration over dt. Since this consumes, you put a minus sign. And there are two molecules, therefore you have to divide by 2, 1 over 2. So if this part is missing, no marks for that one. Therefore, minus half is very important. This one is rate actually. So how do you write the rate of this one? Just then after that, let me explain this one. Then after that, dNO over dt, decomposition of nitric oxide. That is how you usually represent. Then multiply by 2 and divide by minus. That is minus 2 K1 NO squared H2. Why NO squared? There are two molecules of nitric oxide and one molecule of hydrogen. They are equal to the order of the reaction because this is an elementary step. You know that in reaction mechanism, each and every reaction is elementary. So that's why you write that one. Is this clear, students? Any doubts?
Clear, sir.
Okay. So here, if you want to write this is an additional thing. Let's say if someone want to discuss about the rate, you know that this is the rate determining step. You write the rate for that one. Rate is equal to what? You can define the rate based on the reactants or based on the product. When you try to define the based on the reactants, dNO over dt minus half, you know minus is because it consumes, half means there are two molecules. Is equal to what? Can someone tell? Is equal to what?
Plus dN2 over dt.
dH2. Let's first finish this one.
Concentration of H2 over
dH2 over dt, what is the sign? Minus. Because hydrogen is also a reactant, it also consumes. Is equal to plus, as he
Plus
said,
dN2
N2
gas over
over
dt.
dt and d what? H2O2.
H2O over dt.
Yeah. D H2O2 concentration over dt. So you can write any of these parts for the rate of the reaction. But I'm asking rate law for the specifically decomposition of nitric oxide. Therefore, you have to include that. Otherwise, if I just say, write the rate law for this reaction, maybe you can write like that. Maybe another student can write like that. Another student can write like that or that one. But for all of those students, this part is the same. This part is the same. Okay. Some additional stuff. Then the next one, identify the intermediate and write the rate law for the species. Identify the intermediate and write the rate law for that species. What is the intermediate here?
H2O2.
H2O.
H2O2, very good. Now you have to write the rate law for that one. Try. We'll give you maybe 30 seconds. Think about. You have to think about that H2O2 is involved in the first reaction as well as in the second reaction. How do you write and how do you combine? We'll give you 30 seconds. Does the Cat 1 get MCQ paper? Who knows? Could be MCQ or structure. You have to get ready for anything. Okay. Anyone wrote the answer? Would you please share? Okay.
K1 concentration H2O2 is equal
D concentration of H2O2 divided by dt equal to K1 concentration of NO square concentration of H2.
concentration of H2. That's all. Okay, we'll see. Right. So this is the trickiest part of this question. This is the trickiest part because H2O2 is involved in the first reaction as well as in the second reaction. That is why it is called the intermediate, right? So here is we write this one. Please learn. Stop all other work and learn, right? So you have to write the rate based on the intermediate. Intermediate is H2. Usually you write rate is D concentration over dt. Please have that in your mind. D H2O2 concentration over dt is equal to, don't put any signs here. Again, I'm telling, don't put any signs here. Just start with the H2O2 over dt or D any concentration or any intermediate concentration over dt. Now let's go and have a look here. In the first reaction, H2 is H2O2 producing or H2O2 decomposing?
Produced.
Producing. When something is producing, is the rate positive or negative?
Positive.
Positive. Therefore, you put a positive sign. Don't put positive, it is positive. So what is the rate of this reaction? Rate, according to rate law, you write this rate constant is K1 here, right? K1 times concentration of NO squared, concentration of H2. Are you okay with this one? Any doubts? I'm only asking or focusing for this part. You only write the rate law considering the reactants. Don't write K1 times N2 and H2O2 concentration. We don't consider products, only reactants. Since there are two molecules involved, one molecule involved, and this is an elementary, K1 times NO squared plus H2. Then go to the next level. H2O2 now, what is happening? Decomposing or producing?
Decompose.
Decomposing. When something is decomposing, what is the rate? Positive or negative?
Negative.
Then put a negative sign here. Then negative K2 times the rate constant of this one is K2 times what are the reactants? H2O2 and H2. H2O2 to the power 1, H2 to the power 1. Obtaining this equation or writing down this equation is the trickiest part of this question or the entire kinetics course material. So are you okay with this one? Any doubts? Good.
No,
So
sir.
if you listen carefully, you can understand there is nothing much to learn. So I only say start with dH2O2 over dt. Don't put any signs. Because we are going to put signs here in each and every part. That's it. So the second part is done. Then show that H2O2 concentration is this. I hope you remember in the first day school, I explained that you can use steady state approximation to find the concentration of intermediates. So that is what we are going to use now. According to steady state approximation, you know that H2O2 is an intermediate. Therefore, dH2O2 concentration over dt is equal to 0. So steady state approximation, right? We talked about intermediate. We said that di over dt is equal to 0. This is the summary of steady state approximation. Therefore, dH2O2 over dt is equal to 0, which means the entire part is equal to 0. Then after that, you know mathematics. Then after that, you can obtain an equation to find the concentration of the intermediate. What do you all think about this question? Is it easy, hard, or moderate?
Easy, sir.
Very easy. But can you remember I gave this one in the last final examination on our last year's CAT exam? But the majority could not do that. That's because you have not studied. You have not studied. That's why. Some students, they know the theory, but they don't know how to apply it properly. Okay. Okay. Therefore, please study well. Right. So that is an example. So I just wanted to actually explain this one with an example. Now you understand the complex reaction. So let's go to the next one. What's happening here? Sure. Sir, can you use another color pen to write? Okay. So let's. So can you all hear me properly, students?
Yes,
Yes.
Okay, okay. Then someone else's problem. Okay, let me hide this. Right. So let me use maybe blue color. Right. Okay. So activity 4. Now we are going to talk about concurrent or parallel, or sometimes you call them simultaneous equations, reactions, concurrent reactions, parallel reactions, or simultaneous reactions. Activity. Consider the given first order parallel reaction and answer the questions below. Parallel reactions are like reactions. You have a starting material, then you produce two products simultaneously. These ones are called parallel reactions. From A, you get B. At the same time, you get C also. Then rate constants are K1 and K2. So such reactions are called parallel reactions, right? So considering this one, you have to answer this one. If the initial concentration of A is simple A and after time interval of T, the amount of A reacted to form B is X1 and that reacted to form C is X2. K1 and K2 being the respective rate constant, show that dx1 over dt is equal to this and dx2 over dt is equal to this. Then after that, show that ln A over A minus x is equal to this. Okay. So let's see how to do this question. Right. So first of all, please draw the diagram and mark the information you know. A gives B and A gives C, rate constant K1 and K2. At time is equal to 0, concentration of A is A because it is here, right? At time is equal to T, let's say amount of X is reacting. Amount of X. So at time is equal to T, the amount of A reacted is simple X. Therefore, the remaining amount is A minus X. If minus X is reacting, the remaining amount is A. Then after that, right, at time is equal to C, concentration of B is equal to 0. At time is equal to T, concentration of B is X1 because it is mentioned here. Then at time is equal to T, the concentration of C is equal to X2. So now you know that X is equal to what? X1 plus X2 because it produces from A, right? So you have to identify this one. This is very important. You should know that the total amount dissociated is equal to amount of B form plus amount of C form. Right. Now you have to write the rate equations and try to combine each other. Okay. Let's write the rate equation for B. Right? Consider this equation. A to B. You have to write dB over dt. dB over dt, don't put any of the signs. We can put signs later. That's the rule. If you can follow that, you will get very good answers for the questions, right? Just write dB over dt, rate of B. So the rate constant is K1, the reactant is A, K1 into A to the power 1 because there is only one molecule. So here in level 4, all these reactions, chain reactions, simultaneous reaction, whatever the reaction. So assume that these are elementary reactions. So in this question, it is not given, but if you For the exam, I will give a different question, including all the information. But let's say if that information is also not provided, please know that these complex reactions are elementary reactions. Therefore, K1 times A, the sign is plus because B is what? It's a product. It is producing. It is producing, therefore, this sign is plus. Therefore, dB over dt is equal to K1 times A. Then let's write an equation for dC, dC over dt. C also producing dC over dt. Rate constant is K1. The reactant is A, that is K1 times A. Sorry, K2 times A. Again, the sign is positive because C is producing. Are you all okay with writing these two equations? Writing rate equation for B and writing rate equation for C. Are you all okay?
Yes, sir.
Very good. Now let's try to do some math. We know that at time t, the concentration of B is x1. Therefore, instead of B, you write x1. This is K1 times what is the concentration of A at time t? A minus x. Then write A minus x. And this one is dx2 over dt, K2 time instead of A. What is concentration of A at time t? A minus x. So that is the first question. Very easy. Nothing. Simple. Right. Then you have to show something. You have to do some further simplification. Right now we are going to prove this equation. So how do you do that? I told you that you should know that x is equal to x1 plus x2. This is a fundamental thing. Then take that one. X is equal to x1 plus x2. Then differentiate everything. Differentiate everything with respect to time. Therefore, this is dx over dt. This one would be dx1 over dt. This one would be dx2 over dt. Differentiating with respect to time. So dx over dt, you know that dx1 over dt. That's why we wrote these two equations before. dx1 dt is equal to k1 times a minus x. dx2 over dt is k2 times a minus x. Now, a minus x is common. Take that out. Therefore, this is, you can rearrange that k1 plus k2 into a minus x. That is dx over dt. Now, separation of variables. So x terms, you write this part 1 over a minus x dx is equal to k1 into k2 times multiplied by dt. This part is separation of variable. This is also a differential equation. You have to simplify this differential equation. That's what we are going to do. Right? So 1 over a minus x dx, k1 plus k2 times dt. So you are going to integrate both sides. Let's find the limits. So here the variable is x. Here the variable is t. So how the exchange? Exchange from 0 to x, right? The variable x, it changes from 0 to x. Here the time changes from 0 to t. The variable is x, it changes. Initially, there is no dissociation. Therefore, x is equal to 0. At time t, the dissociation is x. That's why the limits are from 0 to x. Okay. Here it is further mentioned here. Right now, apply the math. I'm not going to explain. That's your duty to learn mathematics. When you differentiate 1 over x, so what is, when you integrate 1 over x, what is the answer?
ln
When
x.
you, ln x plus c. When you integrate 1 over minus x, what is the answer?
Minus
Minus
ln.
Minus
sign,
ln
yeah,
x.
no harm, minus sign, minus ln x plus c. Right, then this one, integration 1 over x plus a dx. Now you had x, now x plus a, or x minus a, whatever, x plus or minus a. Right, when you have 1 over something, ln that thing, x plus or minus a, right? So here you have x. When you differentiate x, the answer is 1. Therefore, the answer is ln x plus or minus a. Let's say when you have 1 over x plus a, the answer is ln x plus a. If you have 1 over x minus a, the answer is ln x minus a plus c. So this change, when you have a system like this, 1 over a minus x dx, right? So we have done these type of integration. Now the answer is ln a minus x. But don't forget that you have a minus 1 here, minus x. So you have to differentiate this one and write the answer there. Differentiate this part and write the answer there. Differentiate. When you differentiate a, the answer is 0. When you differentiate minus x, the answer is minus 1. Therefore, the answer is minus ln a minus x plus c, right? So you have to remember this one, integration 1 over a minus x dx is equal to minus ln a minus x plus c. So without knowing that one, you cannot do this one. So that's why when you integrate a minus x, I put minus ln something. Then after that, apply the limits and simplify, right? So you will have an equation like this. You know that ln terms you can combine. That means ln a over a minus x is equal to k1 plus k2 times t. So that is the integrated rate law for this simultaneous reaction. The integrated rate law. So this one is the differential rate law. This is the differential rate law for this simultaneous reaction. This is the integrated rate law for this simultaneous reaction. Is it clear or not? There is nothing much to learn. Sometimes some of you guys feel like this is tricky or this is hard. That's because you don't know mathematics. There is no big deal with the chemistry here. Very little chemistry, but lots of mathematics. That is not my duty because I hope that you all have passed CYE 3200. Therefore, please go through your maths note, okay? All right,
Excuse me, sir.
students. Yep.
So why we add x1 plus x2 at the beginning?
X1 plus X2. Otherwise, you cannot prove this one because the total dissociation is X1 plus X2. So that is what given in the question also. Without putting that one, you cannot obtain this. Okay. Any other questions? All right. Looks like you understood. Okay. So that is concurrent reactions or parallel or simultaneous reaction, right? So another activity, very simple activity. Write down the rate equation differential form for the first order reaction of the form A to B and hence derive the corresponding integrated form using the standard symbols. So we have done this one. I just wanted to do this one because there are some different ways of obtaining the answers. So in this one, let me go back a few slides. So in this one, this is also first order reaction, right? So we use different symbols to obtain the equation. ln A is equal to ln KT plus ln A naught. If you want, you can further simplify this one. What is that? ln, right? You can, if you take this one into this side. Okay, let's take from this one. This is ln A. If you take this one into this side, that is minus ln A naught, which means division is equal to KT minus. Or other way around, if you change the sign, KT is equal to, put KT into this side, take ln A into this side, right? Or then which means this one is ln A naught minus ln A. Same thing, no? Same equation, right? Therefore, KT is equal to ln A naught divided by ln A. Same equation, because in this equation you have a minus sign. In this equation you don't have minus sign, logarithm upside down. Here A over A naught, here A naught over A. That's why you don't have a minus sign here. So you can actually rearrange these ones. Same thing you are rearranging. So now we are going to show the same thing. I hope you can remember the symbols and all. Initial concentration of A is A naught. Now we are going to consider the dissociation to obtain the same equation, right? So that is the activity. So look at this activity. A gives products dA over dt. Now you can write that one, because I told you one thing, right? Don't write positive or negative signs in that side. You can include those signs later, right? The rate of this reaction, because there is a dA over dt, just start positive. dA over dt, then rate constant is K, right? The rate constant is K. K times concentration of A, right? So consider this one is elementary always. Elementary reaction, K times A. So you know that A is a reactant and it is consuming. That is why you put minus sign here. This is also the rate law. But earlier you wrote the rate law in level 3, minus dA over dt is equal to K times A to the power 1. So now you write dA over dt is equal to minus K times A. Both are the same, right? Nothing, no difference. So if you just write like this, it is easier for this class. Then you can obtain any other relationships. Okay, at time is equal to 0, A is simple A. Consider that one, simple A. At time t, A is equal to A minus X because the dissociation is X. Right now, we are going to use a different approach. Instead of A, you write the A minus X. Here A is A minus X. Now open the brackets in this differentiation because A is a constant. Therefore, dA over dt minus dx over dt is equal to minus K, this one. You know that when you differentiate a constant, the answer is 0. You know that the initial concentration of A is constant. Therefore, when you differentiate this one, the answer is 0. Therefore, you will have minus dx over dt is equal to minus K times A minus X. Now, minus and minus cancels off. Therefore, dx over dt is equal to K times A minus X. Right now, you can integrate separation of variables 1 over A minus X dx is equal to K dt, because this A minus X you can get into that side K dt. Then integration from 0 to X, the variable is X. X varies from 0 to X. At the beginning, no dissociation, therefore 0. At time is equal to T, the dissociation is X. Time varies from 0 to T. Here are the limits. Then 1 over X, you know that when you integrate minus ln X, ln A minus X, then apply the units and you can rearrange the equation. That is also ln A over A minus X is equal to KT. So for this equation also, you got the same thing. So this one also, we had K1 and K2, right? ln A over A minus X is equal to K1 plus K2 times T. Consecutive reactions. ln A over A minus X, K1 plus K2 T. Now you only have one thing, that is ln A over A minus X, K times T. Right? So what is the importance here? Right. Do you see any pattern? I already explained. Do you see any pattern? A to B, K1, ln A over A minus X is equal to K1 T. A to B, A to C, rate constants are K1, K2. Again, ln A over A minus x is equal to K1 plus K2 times T. The
So the
summation of the rate
K1,
constant.
K2, K3 are
Yeah.
consecutive join.
Yeah. Now, my question, can you predict the integrated form of the rate equation for the concurrent reaction given below? What is the answer?
ln A
K1
over
plus
A
K2 plus
minus x is
K3
equal to
into T.
K1 plus K2 plus K3 into T.
Very good. ln A over A minus x, because only one reactant, one reactant, one reactant. That's why ln A over A minus x. Three reactions are there, K1 plus K2 plus K3 times T. So you should know the pattern. I'm going to ask these type of questions for MCQ questions. Okay. Right. The third one we have to learn is consecutive reactions. Right. Consecutive reactions. Consecutive. So what type of reactions are that? A gives B, then B gives C. Right? A gives B, B gives C. K1, K2. Consider the given first order consecutive reaction and answer the equation below. So please note that all of these reactions are first order or elementary reaction. Derive expressions for A, B, and C and in terms of initial concentration of A naught, and two rate constants K1 and K2. I gave this question for the final year exam last year. Very easy, but the majority could not do this one. Okay. Derive expressions for A, B, and C in terms of initial concentration of A naught, and two rate constants K1 and K2. So the question asks, because this reaction is happening inside in your reaction container or something, right? You have to derive an equation to represent the concentration of A. That is the question basically. How do you find the concentration of A, right? Okay, let's start that. So first of all, to find the concentration of A, you have to write the rate law with respect to A. Rate with respect to A, that is dA over dt, right? So you have to consider this reaction. A involves only this one, only in this one, right? A into B. K1, the rate constant is K1 times A to the power 1. So what happens in this reaction? So only this reaction involves. When you write this one, only that reaction involves A to B. So that's where only A involves, right? So A consumes in this reaction because A is a reactant, it consumes. Therefore, it is minus K1A. Are you all okay with this one? This is the trickiest part of this question. Write in the rate laws. Is that okay? Okay, good. So
Yes, sir.
now mathematics, integration, right? So what will happen at time t, at time is equal to 0, concentration of A is A naught. At time is equal to T, concentration of A is concentration of A. You can write like that, right? You are integrating from A naught to A. At the beginning, A naught to A, the time is, so separate into variables, okay? I did not write that one because this one is A, 1 over A, dA. This is minus K1 times dt, integrate both sides from 0 to T. The time varies from 0 to T. So when you integrate this one, that is ln. I have again not written one step here. What is that one step? When you integrate ln A, sorry, when you integrate 1 over ln A, what are the limits from A naught to A? So these are the things you have to practice at home. Write down each and every step. Then only you will understand. Is equal to minus K times. When you integrate dt, the answer is T from 0 to T. The missing step, right? Therefore, apply the limits. First upper limit ln A, then the lower limit, then ln A naught minus K1 here, K1 because this is K1 times upper limit T, lower limit 0, T minus 0 is T. Then logarithm rule, right? You know that log AB is equal to log A plus log B, and log A over B is equal to log A minus log b. You know these ones from level 3. So here something log a minus log b, something like this, you can combine, which means log ln a over a naught is equal to minus kt. Now get rid of this ln. Right, let's say you have something like this. Logarithm of a to the base c is equal to c. So how do you write the index form? Logarithm of a to the base b is equal to c. What is the index form of this? Students?
B to the power
Log
C is
BC.
A.
BC
Yeah,
to the
a
power
is
C.
equal to b to the power c, right? A is equal to b to the power c. Now you have ln x is equal to p. What is this? ln means logarithm of x to the base e is equal to p. Therefore, x is equal to e to the power p. So you are applying the same thing, which means this part, ln that part, x is just like a over a naught, the entire part. That entire part is equal to, which means x is equal to e to the power p. E to the power p is what? Minus k1t. E to the power minus k1t. See, everything is logarithm math. If you cannot remember the basic logarithm, you cannot do this question. Now you have to subject the term capital A, concentration of A is equal to A naught times e to the power minus k1t. Right? So since this is an exponential one, so you can plot this one. I don't expect that level here. So if you can obtain this relationship, that's more than enough. I don't expect you to plot graphs, right? There are some past paper questions before, several years before. So I don't expect that one here. Don't worry. In the book, I think they have plotted the graphs also. This is exponential because e to the power curves. That's okay. If you can derive this, that's more than enough. Is this okay? Clear?
Yes, sir.
Okay. So one part is done. We have obtained an equation for concentration of A. Now let's do for B. So I'm going to clean this, clear that one. Then B, same thing, B. So B, it is easy because B is an intermediate. From A, B forms, then again B reacts to give C. It is just like intermediate, right? B forms, then dissociates. Formation and dissociation. So these ones are called intermediates. Then forget about that one. Then first write the rate law for B. Rate law for B means dB over dt. So now you have to consider both reactions because B is involved in both reactions. Right now, let's start with, don't put any signs here. Just dB over dt is equal to, consider the first reaction, this one. So is B producing or consuming in this one?
Consume.
This one, in this reaction,
Producing.
producing,
Producing.
not consuming. The B is producing from A. Therefore, the rate is positive. The rate is positive. So what is the value according to rate law? Rate constant is K1 times what is the reactant is A. Therefore, K1 times A. So that is first part. Then go to the next reaction. In this reaction, is B producing or consuming?
Same.
Consuming. Consuming means rate is negative. See, put a negative sign here. So this reaction, consider this reaction. How can you write the rate law? K2 times the reactant. Now the reactant is B, therefore K2 times B. That's all. This is the trickiest part of this question. Is this okay? Yeah, looks like it is okay. Now we know that B is just like an intermediate, therefore apply the steady state approximation. According to SSA, dB over dt. dB over dt is equal to 0 because B produces, at the same time B consumes. Therefore, dB over dt is equal to 0, which means the entire part is equal to 0. Therefore, you can write, therefore, B is equal to K1 over K2 times A. You have already found an equation, an expression for A. Therefore, substitute that one. Then you will get this one for B. Is that clear? Then C, right? Very easy. C, you know that the initial concentration is A naught, right? Right. From A naught only you produce this one. T is equal to 0, concentration of A is equal to A naught. Then when time is T, concentration of A is equal to concentration of A. From A naught only you produce B and you produce C. Therefore, what can you write? Concentration of A naught is equal to concentration of A plus concentration of B plus concentration of C when T is equal to T. Do you agree with this? The initial concentration is equal to at time T concentration of A and the remaining concentration of A and formed concentration of B and formed concentration of C. This is C, okay, not some. Right? Therefore, the concentration of C is equal to what? A naught minus A minus B. Therefore, concentration of C is equal to A naught minus concentration of A minus concentration of B. You know the terms. Instead of A, you write that one. Instead of B, you write that one. If you want to further simplify, you can take A naught out is equal to 1 minus e to the power minus K1T minus K1 over K2 e to the power minus K1 over T. If you want to further simplify, but that's okay. If you just leave like this, I would give full marks. So that is how you obtain the concentration. The questions are like this for consecutive reactions. So here to get the concentration of C, you don't need to write rate laws because there is a very easy method as I shown here to calculate the concentration. You only need to derive the rate laws for A and B, then do the question simplification like this. Is this okay? Clear?
Yes, sir.
All right. Next. Yeah. The last one is reversible reactions. Reversible reactions, right? A gives products, then A gives B gives A. Reversible reaction. The rate constant of the forward reaction is K1. The rate constant of the backward reaction is K2, right? Consider the given first order. It's given first order reversible reaction and answer the questions below. First order reaction. So let's put this chart actually, it's easier. When T is equal to 0, concentration of A is simple A, concentration of B is 0 because at the beginning, no B is formed. At time T, particular time, if the dissociation is X, concentration of A is A minus X. Now the concentration of B is X. So if X dissociates, then the same amount of B is produced. That's why the concentration of B is X. Let's say you want to talk about the equilibrium situation at when T is equal to T equilibrium, the concentration of A is equal to A equilibrium dissociation, X equilibrium, then B is equal to X equilibrium. So you just write like that. Now, if the initial concentration is, so it is there, right? So all I explained here, written here. Now what you have to show is, if the initial concentration is A and after time interval of T and TEQ, the amounts of A reacted to form B is X and X equilibrium. Show that the equilibrium constant K is given by K1 over K2. You may have studied these ones. Maybe, I don't know, for A-levels, some teachers, they teach the relationship between the equilibrium constant and rate constant. So here is the answer. The rate constant is equal to the actually the ratio between the relationship between the rate constant and the equilibrium constant, capital K is equal to K1 over K2. The rate constant of the forward reaction divided by the rate constant of the backward reaction. So now we are going to prove this. How? Yeah, just few steps. First, you have to consider A. You have to write the rate equation for A. dA over dt. So I'm telling this is the trickiest part of this question. All the other parts, mathematics, integration. Okay, let's try to understand this one. dA over dt. Don't write any plus or minus signs here. dA over dt is equal to, come here. First reaction, A gives products. Forward reaction, A gives products. Is A decomposing or is A producing in the forward reaction? What is the answer? Is A producing or is A consuming?
Consume.
Consuming. A gives B, no? Consuming. Therefore, rate should be negative. Negative. So, rate constant is K1. The reactant is A. That is K1 times A to the power 1 because they are first order, or these are elementary reaction. You have to elementary reaction. So don't worry, in the exam, I'm going to give you all the required terminologies, then you will not be in any trouble. Elementary, because this is one. Complex reactions, they are elementary, I told you. K1 times A. Then we are talking about A. So we talk about the forward. Now the backward reaction. In the backward reaction, is A producing or decomposing?
Producing.
Producing. Backward reaction, it is producing from B. When it is producing, the reaction rate is what? Plus. What is this reaction? B to A. B to A reaction, rate constant is K2. B to A, what is the reactant now? B. Therefore, you have to write B here. Is that clear?
Yes, sir.
Good. Right, now it's okay. It's over. Now the hardest part is done. Now let's do the math. Concentration of A at time t, that is, instead of A, you write A minus X. Instead of A, you write A minus X. It's here. Instead of B, you write X. See? Then after that, open the brackets. I explained this part earlier also. If you open this one, this is dA over dt minus dx over dt. Since A is a constant, the value of this one is 0. The initial concentration, it's a constant. When you differentiate a constant, the answer is 0. Therefore, this is minus dx over dt. Here, the same part is here. Then multiply by minus dx over dt is equal to plus k1 a minus x minus k2x. Now what we are going to do? At equilibrium, the rate of forward reaction and the rate of backward reaction are equal. So you should know this one. That comes from your fundamental knowledge. Equilibrium. At equilibrium, how do you define the equilibrium? I don't know, maybe in level 3, we don't study any equilibrium here. So that's based on A-level knowledge, right? So any kind of equilibrium, which means when you have a reversible reaction, the meaning of equilibrium means rate of forward reaction is equal to rate of backward reaction, which means that dx over dt is equal to 0. Forward reaction, because dx is the dissociation. There is no dissociation kind of thing, which means that dx over dt is equal to 0. Now, according to equilibrium, we are applying the equilibrium constant, dx over dt is equal to 0. Since you are considering the equilibrium constant, instead of x, you write ex, which means this part is 0 now, because dx over dt is 0. Therefore, this one becomes k1 times a x equilibrium minus k2 times x equilibrium is equal to 0. Now rearrange this one, put this term into the other side. This is positive. Now K1 over K2 is equal to X equilibrium over A minus X equilibrium. What is X equilibrium? X equilibrium means concentration of B. What is A minus X equilibrium? The concentration of A. Therefore, this instead of that part, you write what? Concentration of B over A, right? Therefore, capital K is, so this is equation 1, okay? Then take at equilibrium K, equilibrium constant. How do you write the equilibrium constant? Equilibrium constant is B over A, right? You know that B is the product over reactant. Then product concentration is X equilibrium over A minus X equilibrium, which means these two are equal. Therefore, K is equal to K1 over K2. Or, as I explained before, we know that X equilibrium is what? B. A minus X equilibrium is A. B over A is capital K. Somehow, you can prove that the equilibrium constant is equal to the ratio between the rate constants of the forward and backward. Yeah. So you have to keep this in mind for MCQ question. Keep this in mind for MCQ question. Is that okay? Understood? Right. So after the lecture, so I'm going to share the Zoom recording on lecture notes, etc. So please go through these ones and try to prove yourself. First, go with the slides and listen to my lecture, understand, try to understand that. Then after that, take the activity only. Don't look at the answer. Take the activity only and try to derive everything by yourself. Then you have the answer with you. Then just try to understand. That is called the self-learning. So without doing some self-learning, you cannot study. Okay, you cannot understand the content. Yep, that's all actually. So I have some MCQ question. If you would like to talk about these questions, we can do. Otherwise, I will let you to do that. What is your preference?
Sir, first we will do, sir. After, if you have any doubts, we will ask you, sir.
Yep, very good. Let's go through the lecture material first. Then I have the answers also, right? So answers also there, but don't look at the answers. Try to do the questions. First go through the lecture notes. Try to understand the theory. Then after that, try to do these MCQ questions. So answer is already provided. If your answer matches my answer, that's okay. Then even if you cannot understand, please discuss. We can help you. We can do that one in our Telegram group. All right. What do you all think? Do you think that you can grab the you can follow this one? What do you all think? Any comments? What do you think about the content? Just few slides. Just remove the first 2 slides. Only 10 slides you have to study. And the majority is level 3 stuff. So we only studied the complex reactions in level 4. What do you all think, students? What is your opinion? Do you think that you can follow or not?
Yes, can follow.
Christina, what you want to tell?
I think can follow, sir.
You can follow? Okay, great. So then, do you have any doubts?
No, sir.
Right.
My integration is a little bit weak,
Mm-hmm.
but
Yeah.
am working on it, sir.
Yeah, improve that one. Take the notes and go through the integration. If you want, I can share my level 3 integration lecture. So go through that one. You need that one. Without integration, you cannot do kinetics in level 4. So students are struggling because they don't know how to solve the questions, problems using integration. That's why. I hope you have very good knowledge, chemistry knowledge, but your mathematics knowledge is poor. That is why this subject is hard. Right? So there will be one full question for the final exam from this year onward, right? I explained that one in the day school. So we will provide everything after the pre-registration process started tomorrow, because you guys do not have access to OULMs, right? So please understand your shortcomings, right? So please work hard, go through the math notes. If you want any help, then I'm here to do. Okay, so if you do not have any other questions, we can wind up the meeting. All right?
Okay, sir.
Good night.
Thank you, sir. Good night.
Thank you for joining today.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.